Hello and welcome again to my Physical Science online video lecture supplement series. Today's video, I wanted to do another post-quiz review. So this is sort of the ongoing series by request from the discussion boards. This one is the post-quiz review for the quiz which covers the section on waves and on sound. So for those of you who are following along with your notes or textbook, this is chapter 6 of your notes. That's the chapter on waves and sound. So chapter 6 from your Shipman, Wilson, Higgins and Torres Physical Science text. So let's go ahead and look at what the item analysis has to tell us about this quiz. Well, it looks like our average score was a 73.5 roughly, so like a very high C or low B according to my grading scale. This says there were 8 easy questions, 10 medium questions, 3 hard questions, but if you look at the hard questions, 2 of those 3 only had 3 people that actually got to see those questions. So I guess I'm going to be working some medium difficulty questions today. Although maybe I will go ahead and consider some of those harder questions. So let's look at them. The first one that I'll look at is, what is the period of a set of waves in water which are 6.0 meters from peak, that is highest point, to trough, lowest point, and which arrive every 2.0 seconds and have peaks 4 meters apart? There's a lot of information given in this problem. The only piece of information that you actually need is that they are arriving every 2 seconds. This right here is the period. So the period is 2.0 seconds. 0% of the people who attempted this got it right. It was a multiple choice question though, and the choices basically included 6.0 meters, 1.5, 3.0 meters, 4.0 meters, 2.0 meters per second, 0.5 meters per second, 3.0 meters per second, and none of the above. Well, not a single one of those choices was actually a time, and since period is a time, the answer is none of the above. Specifically, none of the choices were 2.0 seconds, so that eliminates that one. The next one that's on that list of frequently missed ones, the other hard one, the only hard question apparently that everybody had according to the analytics, was marked EXE8, and it was how many times louder is 59 decibels than 40 decibels. I actually have already answered this question in the discussion boards, but I might as well go ahead and include it in the video in case some of you didn't read that discussion board and somehow are stumbling across these videos anyway. So the basic rule here, there's 2 ways you could approach it. One is the work it out equation way, which basically says that the decibel level is going to be 10 times the log of the intensity divided by some base intensity. And in fact, this one is actually giving us 2 different intensities. So we could actually use like delta B is the log of the intensity 2 divided by intensity 1, where delta beta is basically defined as beta 2 minus beta 1. Alright, so what this basically means is that we have 59 minus 40 because the intensities were 59 decibels versus 40 decibels, and that's going to be equal to 10 times the log of I2 over I1. Okay, so this is basically saying we could divide both sides by 10 here. That gets rid of this. This difference is 19, so we'd have 1.9 is equal to the log of I2 over I1, and that basically means that I2 over I1 is 10 raised to the power of 1.9. So stick that guy into your calculator. What do you get? You get 79.43 blah blah blah. So this is about 79.4. Okay, the actual answer on the quiz basically would have included this answer. I'm allowed to enter an answer and then an answer range. So, I put 80 plus or minus 1. That means anywhere from 79 up to 81 would have been correct. To see why it is that I put it that way, what we need to do is look back at our note, specifically at table 6.1 in our notes. And so what we see is over here this little column that says delta dB, and we basically see a couple little notes here. Delta 3 decibels, so if you change the intensity level by 3 decibels, then you get a factor of 2 increase, and that's even set up here in the main title of this particular slide in the notes. Increasing by 3 decibels means about 2 times as intense. If you want to be more precise, it's 1.995 times as intense. And an increase of 10 decibels means 10 times as intense. And you notice that for every increase in 10 here, we get another factor of 10 here. So let's go back to the data that's actually given in this problem. We want to know how much louder is 59 decibels than 40 decibels. So the delta beta is 59 minus 40, that is 19. Okay, so 19 can be given by, and I guess this is almost some Common Core bullshit, but anyway, you can break up 19 to be 10 plus 3 plus 3 plus 3. So this right here means 10 times plus, so 10 times by 2 times by 2 times by 2 times. So each of these plus 3 is another 2 times more intense. So if you multiply these 4 things together, you have 10 times 2 times 2 times 2. 80. And so your delta beta should be implies that I2 over I1 is about 80 times, or is about a factor of 80. So I2 is about 80 times I1. So that's basically the other way that you can get to that answer. And again, this also actually happens to be related to one of the examples that I specifically worked in the text. Specifically, it said EXA 8, so that means look at example 8 from my notes. And in example 8, I actually did a 66 decibel versus 60 decibel, so I kind of changed the numbers a little bit, but other than that, it's the same process. So for our last problem from the quiz that I'm going to work through, this one's the one that the most people got right of these three. About a third of you got this one right, as opposed to 18% or 0%. For this one, you have that waves are moving on a lake with a speed of 2 meters per second. They have a distance 1.5 meters between adjacent crests, and each crest is 0.3 meters higher than the trough between crests at a certain point 10 meters from shore. And so the question is, what is the amplitude of the waves in meters? So this one, basically, you might want to draw out a picture of what these waves are looking like. So this is basically, maybe if we were to draw the wave like something like this, just as a simple sketch. Alright, so the crest right here, so here's the crest. This right here would be a trough. And then this distance from crest to trough is given as 0.3 meters. And we're told that this is from shore. So let's say here's shore. This distance right here is 10 meters. And then these are moving with some speed, 2.0 meters per second, and that there's a distance between consecutive peaks or consecutive troughs of 1.5 meters. So this is also 1.5 meters. Alright, so that's a simple sketch of what this thing looks like. The only piece of information we want to know, though, is what is the amplitude of the waves in meters, and the relevant piece of information for that is this piece of information, which is basically this right here. Amplitude is basically how tall are the waves. So amplitude goes with how tall are waves with respect to basically, you could think of it as calm water, meaning if there were no waves on the water and you were to compare that to what we have here, how tall would they be? Well, no waves on the water would mean that you'd basically have water that looks something like this. So in fact, we need to know what this distance is, and this distance and this distance are basically equal. You could think of it as the water that would be here sort of is here. That's not exactly entirely true, by the way, but it's close enough to get the right answer here. These waves on the ocean are both a longitudinal and a transverse oscillation together. Ditto for lakes, since this thing is a lake. In any case, you can take this number and divide it by 2, so the amplitude must be 0.15 meters. And that is how we solve this question. So, thank you for watching, and I hope you found these quick review examples helpful.